In this video, I am going to solve KCET 2019 Mathematics paper part 1 from question number 1 to 10. Now let us move on to the question number 1. This question based on the chapter matrices, particularly find the inverse of matrices. So let us see the question, find the inverse of matrix. So I am not solving this question by an usual method because this is lengthy process. I am solving by a shortcut method. So we know that in this case formula A into A inverse is equal to identity matrix. Here A is given. This is given matrix. This is equal to A. So we have to find out the A inverse. So A inverse present in the any one option among 4. So here in this case option B satisfies this equation. So option B is correct. So A, put A value 2, 5, 0, 0, 1, 1. Minus 1 0 3 into A inverse 3 minus 15 5 minus 1 6 minus 2 1 1 minus 5 2 LHS. We can take LHS in this case. So multiply these two matrices, we get identity I. So option B is correct. So multiply this, 2 3s are 6, minus 5 1, minus 13 plus 13 0, plus 10 minus 10 0, here minus 1 plus 1 0, so plus 6 minus 5 1, next 0, minus 2 plus 2 0, here minus 3 plus 3 0, next minus 15 plus 15, minus 15 plus 15 0. So next minus 5 plus 6 1. So we get identity matrix. So this equation satisfy option B only in this case, hence option B is correct. A inverse of this matrix is this is. So easy question, all the student attend this question. Take down. So now let us move on to the question number 2. Once again this question based on the chapter matrices. Usually they ask 2 or 3 question on this chapter in KCET. Let us take second question. Particularly it is based on the topic transpose of matrices, Q symmetric and symmetric. So let us see the question. If P and Q are symmetric matrices, it is given P transpose is equal to P and also Q transpose is equal to Q because symmetric matrices of the same order. Then find the PQ minus QP is what in this case. So here we take X is equal to PQ in minus QP. Apply transpose on both sides. PQ minus QP transpose, this becomes according to the properties of transpose PQ whole transpose minus QP whole transpose. Again once again apply the transpose of matrices, properties of transpose of matrices. PQ whole transpose becomes Q transpose into P transpose minus P transpose into Q transpose. We know that P transpose equal to P and Q transpose equal to Q. It is given in the question. So replace Q transpose equal to Q, P transpose equal to P, P transpose equal to P, Q transpose equal to Q. Here in this case minus take outside, it becomes PQ minus QP. So X transpose, this is equation 1, X transpose equal to minus X in this case from 1. So hence according to the skew symmetric matrix definition, this is skew symmetric matrix. PQ minus QP is skew symmetric. So this is easy question. All the students solve this question. Take down. Now let us move on to the question number 3. Once again this question based on the chapter matrices, particularly algebra on matrices and also the transpose of matrices. Let us see the question. If 3 into A plus 4B dash equal to the given matrices and also 2B minus 3A transpose is also given. So in this case we have to find out B value. So we know that one statement, if order of the two matrices are equal, then we can add these two matrices or subtract. So here in this case, if we change this order of this matrix to equal to this and then add, we get the answer B. So first we change the order of this matrix. This is becomes order, apply the transpose on both sides, it becomes 3A transpose plus 4B whole transpose becomes B, and this is becomes 7 minus 10 70 0 6 31. So this is equation 1. Add equation 1 with the 2 means what? In this case this is equation 2. So 2B minus 3 into A dash equal to the minus 1 18 4 0 minus 5 minus 7. Add these two equations, we get the answer B. So here minus 3A transpose plus 3A transpose cancel each other, 4B plus 2B 6B, it becomes 7 minus 1 6 18 minus 10 4 minus 6 minus 10 plus 4 minus 6 plus 6 17 minus 5, in this case plus 12, 31 minus 5 24. Now divided by 6 on both sides, we get the required answer. B is equal to 1 3 minus 1 plus 1 2 3. 1 3 minus 1 plus 1 2, so 4. This is the correct answer. Option D is correct in this case. This is easy question because they have already solved this type of question in NCERT textbook. Take down. Now let us move on to the question number 4. This question based on the chapter Determinant. Usually they ask 2 or 3 questions on this chapter in KCET. Let us take a first question in this case. Question number 4. If A is given and B is also given matrices, then find the determinant of A into B transpose. Using properties of determinant rule, we have to find out the answer of this question. So in this case, take A, determinant of A, B transpose. According to the rule, this can be written as determinant of A, determinant of B, determinant of B transpose. Determinant of B transpose equal to determinant of B. So transpose of matrix determinant is also same. We know that this rule. So in this case, determinant of A, determinant of B square. Determinant of A becomes 2 1s are 2 minus 12 into determinant of B is 2 2s are 4 plus 1 whole square. So this is minus 10, 4 plus 1 5 square. So 5 square 25 minus 250 is the answer of this question. Minus 250, option C is correct. This is also easy question. All the students solve this question. Take down. So now let us move on to the question number 5. Once again, this question based on the chapter of determinant, particularly cofactor matrix. Now let us see the question. If the value of the third order determinant is 16, the value of the third order determinant is called delta. This is delta. Here delta is given 60, given data. Then the value of the determinant, here third order is given. So we need in this case third order. Here n is equal to 3. N is equal to 3, order of the matrix. Then the value of the determinant, we have to find out the value of the determinant formed by replacing each of its elements by its cofactor. It is called delta dash. We have to find out delta dash. In this case, we need delta dash. So in this case, find the value of the determinant, nothing but in delta dash. This is question mark. This is question mark. Okay. So now using the relation between them, between these three parameters, nothing but delta dash is equal to delta to the power of n minus 1. So put the value n and delta, we get the delta dash value. 16 to the power of 3 minus 1, 2. So in this case 256, 16 square is 256. Answer B is correct. This is the toughest question. Most of the students solve this question easily, but some peoples attend this question difficult. So this is answer is B. Take down. Now let us move on to the question number 6. This question based on the chapter integral, particularly indefinite integral by parts. So using by parts rule, find the value of this integrand. So using the UV rule, already says about that UV rule in 2000 KCET 2014 paper solving. So this is U, this is V. So in this case we take this is I. So I is equal to U take as first constant integration of B sin 3x is equal to what? Integration of sin 3x minus cos 3x divided by 3, again minus, this is the rules. Now differentiate of x cube, successive differentiation, it becomes 3x square. Now integration of this value becomes what? Minus as it is. So sin 3x, differentiation of sin 3x is cos 3x, again 3 into 3, 9 plus, now this is the rule. Now differentiate 3x square, nothing but 6x square, 6x. Now integration of this integrand sin 3x divided by 9, nothing but so plus it becomes cos 3x divided by 27. Now minus, it becomes differentiation of 6x, nothing but 6. Now integrand cos 3x, integration of cos 3x divided by 27, nothing but what? In this case differentiation of sin 3x cos. So sin 3x divided by 3 into 27, 81. So now end. Next step we take, next step this becomes 0 because differentiation of 6 is 0. So end, stop this integration. So we get the required answer, but simplify is there, in the simplification is there. Now simplification completed, we get the required answer. In this case option B is correct. So simplify this, minus x cube cos 3x divided by 3, 3 is a 9, minus into minus plus, here minus is there, plus x square sin 3x divided by 3, this is becomes plus 3 2s are 6, 3 9s are 27, 2x cos 3x divided by 9 minus 2 3s are 6, 2 27s are 81. So 3 2s are 6. Here in this case, sorry, 3 2s are 6, 2 sin 3x divided by 27 plus indefinite integral constant as C. So option C is here, option B is correct. So easy question, all the students solve this question. Take down. Now let us move on to the question number 7. This question based on the chapter application of integral, particularly area between the two curves. Now let us see the question. The area of the region above the x-axis important, included between the parabola y square is equal to x positive x-axis and the circle. So circle not in the standard form, first convert in the standard form, it becomes x minus 1 whole square plus y square is equal to 1. So in this case we need a rough figure of these two graph and these two functions. So here we take circle, both are circle and parabola, both are touch at 0 comma 0, intersect at 0 comma 0 and 1 comma 1, because these 2 points satisfies both the equations simultaneously. Here we take circle first, circle passing through the origin and center at 1 comma 0, radius is 1 and diameter is 2. So 1 comma 0 nothing but here x is equal to 1, here x is equal to 2, x is equal to 0, and Parabola intersect at the circle at the point 0 comma 0 and 1 comma 1. This is 1 comma 1 parabola in positive direction, positive x-axis direction. So in this case we find out the area between the two curves, nothing but circle and parabola. This is this and this. So first we have to find out the area under the parabola from 0 to 1. Add with this find the area under the circle from 1 to 2. So here parabola y is equal to x to the power of 1 by 2 and circle y is equal to 1 minus square root of 1 minus x minus 1 whole square. Now find the area. A is equal to integration from 0 to 1. Find the area under the parabola from 0 to 1, nothing but 0 integration of 0 to 1 x to the power of 1 by 2 plus area under the circle from 1 to 2, nothing but integration from 1 to 2 y square root of 1 minus x minus 1 whole square with respect to x, here also with respect to x. So now integrate x to the power of 1 by 2, nothing but x to the power of 3 by 2 divided by 3 by 2, 2 by 3 from 0 to 1 plus, so this is becomes using the standard result, this can be written as the answer of this part is x minus 1 divided by 2 into square root of 1 minus x minus 1 whole square plus a square by 2, nothing but 1 by 2, in this case a is 1 into sine inverse of x minus 1 by a, nothing but x minus 1 by 1 from 1 to 2. So now apply the limit, apply upper limit in this case only because lower limit, apply the lower limit, this becomes 0. 1 to the power of 3 by 2 1 into 2 by 3 2 by 3 plus apply the upper limit 2 minus 1 1 1 minus 1 0, first part becomes 0, second part only, in this case 1 by 2 sine inverse of 1. Apply the lower limit, these two term becomes 0, so we cannot write. So this is the answer. Simplify this, in this case 2 by 3 plus sine inverse of 1, nothing but pi by 2 into 1 by 2 pi by 4. So answer of this question is 2 by 3 plus pi by 4, but in this case no one option satisfies this, no one option match this answer, so here options are wrong. So grace mark is allotted to this question in KCET exam. Take down. Now let us move on to the question number 8. Once again this question based on the chapter application of integral. Usually they ask 1 or 2 question on this chapter in KCET. Let us take second question. Let us see the question. Find the area of the region bounded by y-axis, important, and sin x, y is equal to sin x and y is equal to cos x between 0 to pi by 2. Draw the rough figure of this question. We need in this case easily find out the answer of this question using this graph. So y-axis, this is y-axis, and draw the graph of cos x and sin x from 0 to pi by 2. So cos x cos 0 1, pi by 2 becomes 0, pi by 2. Sin x sin 0 0, sin pi by 2 1, this is 1. So both are cut at the point x is equal to pi by 4. At x is equal to pi by 4, both are equal. So we have to find out that this is x is equal to 0. Find the area bounded by y-axis, means this is y-axis, and sin x, this is sin x, and cos x, this is cos x. This is the required region. We have to find out the area of this region. So this region, area of this region means what? Find the area under the curve. This is cos x, y is equal to cos x. This is sin x, y is equal to sin x. Find the area under the curve cos x from 0 to pi by 4. Subtract this with the area under the curve sin x from 0 to pi by 4. This is the required answer. So now integrate this. Cos x equal to what? Integration of cos x sin x. Sin x means minus cos x, it becomes plus cos x from 0 to pi by 4. Apply the limits. Sin pi by 4, cos pi by 4, 1 by root 2. So 1 by root 2 plus 1 by root 2 upper limit minus lower limit sin 0 0 cos 0 1. 1 by root 2 plus 1 by root 2, 2 by root 2. 2 can be written as root 2 into root 2. Root 2 cancel. It becomes root 2 minus 1 square units is the required answer. So root 2 minus 1, option D is correct. So this is easy question. All the students solve this question. But this type of question, they has this type of question in theory examination also. It carries 3 marks. Here it carries 1 mark. Take down. Now let us move on to the question number 9. Once again, this question based on the chapter differential equation, particularly find the integration of find the integrating factor of the differential equation. Usually they ask this type of question in KCET every year without fail on this topic. Find the find the integrating factor of the differential equation. So here in this case, take differential equation 2x plus 3y square dy equal to y into dx. Now in this case divided by y into dy on both sides, because it convert into standard form. So 2x plus 3y square, y here in this case divided by y into dy. Dy is removed. In this case 2 into x divided by y plus 3 into y equal to the dx divided by dy. Now it becomes dx divided by dy minus 2 by y plus of minus 2 by y into x is equal to 3y. Now it is in the standard form. So standard form is dx by dy plus px equal to the q. So here in this case p is minus 2 by y. This is q. So find the integrating factor of this differential equation is e to the power of p dy. So here in this case p minus 2 by y into dy, it becomes minus 2 log y. It becomes e power integrating factor e power log of y minus 2. So y minus 2 equal to 1 by y to the power of minus 2 equal to 1 by y square is the answer of this question. Option A is correct. So this is easy question. All the students solve this question. Take down. Now let us move on to the last question of this video, question number 10. Once again, this question based on the chapter differential equation, particularly find the solution, general solution here, particular solution of the given differential equation in this case by using variable separable method. Let us see the question. The equation of the curve passing through the point 1, 1. So draw the rough figure of this question. The curve is there. This curve passing through the point 1, 1 such that the slope of the tangent at any point. Slope of the tangent at any point means this. This is called x, y point. So slope of the tangent at any point x, y according to the second year dy by dx is equal to the product of its coordinates, means x into y equal to x into y. This is the differential equation given. So find the solution of this differential equation. First general solution, and then using the condition 1, 1, this curve passing through the 1, 1, we get the particular solution. So now according to the variable separable method, dy by y d sub x into dx, separate variables. Now apply the integration. It becomes log y. It becomes x square by 2 plus indefinite integral constant c. Now in this case this is curve, required answer is obtained, but this is passing through the point 1, 1. We need in this case particular solution. So put 1, 1 in this equation 1. In 1. So log 1 0, 1 square by 2, 1 by 2. Now see, this implies c becomes minus 1 by 2. Now put c is equal to minus 1 by 2 in equation 1. We get equation 1 becomes log y equal to x square by 2 minus 1 by 2. Now multiply by 2 on both sides. 2 into log y equal to x square minus 1 is the required answer. So 2 into log y is equal to x square minus 1. Option B is correct. This is easy question. So most of the students solve this question, but there's this type of question in theory examination. It carries 3 marks. Here it carries 1 mark. Take down.